In this data set, we are interested to see whether there are differences between different cultivars for the level of infection. And from a breeding perspective, this can of course be very important to know whether you have more resistant or more susceptible germplasm in your breeding program. But oftentimes breeders are not only interested in selecting in a single environment, but also knowing how do varieties respond over multiple environments. And in this experiment we have different levels of soil fertility to represent different types of growing environments. You can study these interaction effects by using an ANOVA analysis on the data set. So in R, if we would like to do that, we use the AOV function, analysis of variance. And that takes as an argument a similar formula from what we had before. So we're looking at the level of infection, and we're seeing whether it can be predicted by the cultivar, but also by the type of soil. We use the multiplication symbol, the star symbol, to say that we're not only interested in the main effects of cultivar and the main effects of soil on the level of infection, but also the interaction between these two factors. And as before, we specify what is the data set that we're working with. Now the output of this function, AOV, we want to save that, and we save it in something which we'll call AOV1 for now. And again we use the backwards assignment symbol. So when we run that, you'll see that there is now another object up here called AOV1. Now to get the ANOVA table, which is what we'd like to see, first of all we use the summary function as we had before, and now we do the summary of AOV1. And we can see here the ANOVA table showing the different terms in our model, so the main effects of cultivar and soil, and also the interaction effects between cultivars and soils. So in this instance we can check the p-value associated with this interaction term, and we find that there's not really much significance associated with that interaction, so we can also consider the main effects separately. If we want to examine the assumptions of this ANOVA, so that the data, or at least the residuals, were normally distributed, and also the variance is constant, then we can plot the output of the AOV function as well. So if we just write plot and AOV1 and press Control Enter, now you'll see down in the console it'll say hit return to see the next plot. So I have to first click down here in order to get this active. If I press Enter, then you'll start to see a number of different plots coming up. And we're mainly interested in the first two of these. So firstly, these are the residuals after fitting the model, and they're plotted against the fitted values. What we're interested to see here is whether there is evidence for heteroscedasticity. There is some suggestion of it, of some sort of relationship here, but on the whole I think it's more or less constant variance across our range of values. If we look at the second plot, this is the QQ plot, this can tell us something about the normality, and again there is a bit of deviation from normality here. But for now we were interested to see whether there was an interaction effect. It doesn't seem to have occurred, so we can look at those separate main effects. And indeed the cultivar is probably the most interesting factor in this experiment, so which is the more resistant cultivar than the others. And we would like to, in this case, compare the different cultivars. Quite a convenient way to do that in R is to use Fisher's LSD test, the least significance difference, and that's a guideline as to whether a difference between two cultivars can be considered significant or not, bearing in mind that there are multiple tests being performed. And that LSD can be calculated in a separate package called the agricole package. Now usually you first have to install the package itself, so you will type agricole. Now I don't actually have to do this because it's already installed on this particular computer, but once you have it installed, you then load it into the current working session, so you use the library function and then library agricole. Once it is loaded, you use the LSD test function. There it is. And the first thing that we specify is the analysis of variance that we just did, and we have to tell it which is the treatment factor that we're interested in. Now in this case the treatment is the cultivar. Excuse my typing. And we press Control Enter. Now nothing has happened apparently, which means actually we haven't captured the output of this function at all. So we have to, for instance, again say LSD1 And now we see LSD1 is a list up here, a list of 5, and in order to access the elements of that list, we again use the dollar symbol, and you can see there's various outputs here, statistics, parameters, and so on. Have a look at the statistics first, and this gives us, for instance, the value of the LSD. So this is the least significant difference between means, cultivar means, which would be considered significant. What is most useful is the groups output, because if we look at this now, it gives us the mean level of infection, so the percentage of infection of the different varieties, and then it groups them using these symbols A and B. So it seems that there are 2 different types of cultivar, Stepto, Morix and Aca, form a single group, so we cannot distinguish them based on the data and the variance associated with that data. And then there's a second group of much more resistant cultivars, Vada and Prestige, which have much lower levels of infection.